All right, people. I think we're on to this one now. So, just like the last one, if you want to pause right now and give these five a chance, which of the following are geometric? You may want to grab a calculator. Remember, geometric means multiplying by the same thing each time. And the way you can check it is to divide one by the previous one. So -6/1. So if you want to give that a shot, pause it, see if you get the answers right. That's awesome. If you want to just work through it with me, totally fine. So -6 divided by 1 is -6. 36 divided by -6 is -6. -216 divided by +36. I believe that is also -6. So we would say this is geometric. Yay. And its common ratio is multiplying by -6. Good. All right. How about the next one? What do we multiply by? Times 2 times 1.5 times not 2 times definitely not 2. So this is not geo, and I would say no common ratio. All right, here we go. Ooh, 1, 2, 6, 12. All right. Again, we're thinking about just multiplication here. 1 to 2 is times 2. Let's see if that stays consistent. Is that times 2? Nope, that's times 3. And that's times 2. It's not consistent, right? This times 3 in between. It could go back and be times 3, times 2, times 3, times 2. That would be a sequence, and we would have a pattern for it, but it would not be a geometric sequence. It's got to be exactly the same ratio each time. So this is not geo, and no common ratio, ditto. All right, 2, 1, 0.5, 0.25. Well, let's do it this way where we take 1 and divide it by the one before it. That's 1/2. 0.5 divided by 1 is 1/2. 0.25 divided by 0.5, all of these equal 1/2, right? 0.5. So yes, Geo, and our common ratio is 1/2 or 0.5, right? Again, you're like, well, it's dividing by 2. We That's good to see that it's dividing by 2 each time. That'll hint you in, right? But we need to turn it into multiplication for our common ratio. Common ratio is what you multiply to get from one to the next one to the next to the next. Okay. All right. Last one. What do we think? Yeah, if you said this is geo, I believe you are right. And the ratio is -9. Okay. Again, we could do it the same way. 81 divided by this divided by this divided by this. Grab your calculator, do a couple of them, see what happens. Okay. We're good. Cool. All right, people. It's formula time. Formula time. All right. Um, Nth term of a geometric sequence. So we're going to build it up kind of the same way we did last time. So A1 equals A1. A1. To get to the second one, I'm going to multiply the first one times the common ratio. Cool. To get to the third one, I'm going to take whatever this was, so A1 times R, and I'm going to multiply it again times another common ratio. Remember, this was just this, right? To get to the next one, A sub 4, the fourth term, I'm going to take this whole previous one and then multiply it by the ratio one more time. Oh, this is kind of like the other one. Remember with all those D's, D and DD and DDD, right? We're kind of getting the idea here. So the general formula is going to be this. The nth term is equal to the first term times the common ratio. And how many are there? 1, 2, 3 when it's 4. There's 2 when it's 3. There's 1 when it's 2. So this is n minus 1. The fourth term will give you 3 r's. The third term, 3 minus 1, will give you 2 r's. Right? Makes sense? Yeah. The idea is here for the first term, 1 minus 1 is 0. The ratio doesn't count, right? It just becomes 1, and you're left with just that. Good. All right. So now we're going to have some fun with this. Given 54, -18, 6, -2, find the nth term for this geometric sequence, then find the seventh term. All right, so the first term is 54. The second term is negative 18. I don't really need more than that because it has told me that this is a geometric sequence, so I don't need to check for that. I can just take negative 18 and divide it by 54. So take 1, divide it by the previous. That will give you the common ratio. I believe this is negative 1/3. Cool. And now I think I have enough. My common ratio is negative 1/3, and I can use my formula. So A sub n, nth term, is equal to the first term, which is 54, times negative 1/3 to the n minus 1. That's it. Okay, if this looks kind of familiar, this is like exponential, either growth or decay. This would be kind of like exponential decay, right? That we just did a couple chapters ago. All right, now I need to find A sub 7. So the seventh term would be 54 times negative 1/3 to the 7 minus 1 power. Oh, is that the sixth power? 54 times negative 1/3 to the sixth power. Oh my gosh, 3 to the sixth. I know this. I know it's, I'm just going to do 3 to this. I don't want to guess. 729. Wowzers, wowzers. And negative 1 to the sixth power is positive 1. So we have 54 times 1 over 729. I think that actually does simplify a little bit. Oh, I think we can divide 27. So this is 54 over 729. I believe 729 is divisible by 27. I think it is 27, actually. Yes, there we go. So 729 divided by 27 is 27. So we're going to divide by 27, top and bottom. 27 on the bottom, 2 on top, and I think that's it. Oof. That number got a little crazy. That's okay. Here we go. Numbers are crazy. All right, two terms of a geometric sequence are A sub 2 equals 12. And A sub 5 equals, negative 768. All right. Got a couple different ways that we can play with this. Let's let's see. I kind of want to do it a certain way. I think we'll just do it. All right, here we go. So let's plug it into the thing. Plug it in. All right, so A sub 2, well, A sub n equals A sub 1 times r to the n minus 1. We'll do this just like we did the other one, but it's going to be just like we remember when we got elimination, right? So two equations with two variables, but this is going to have a little twist. It's going to be a funky twist. Some of you may not like it, and then I'll show you a little thing you can do. So let's plug in. So the second term is 12. So 12 is the second term. So that's going to be the first term times r. It's the second. So 2 minus 1. The other one is going to be negative 768 equals, and that's the fifth term. So a sub 1 times r to the 5 minus 1. All right, so let's make these look a little nicer. 12 equals a sub 1, the first term, times r. 2 minus 1 is just r. And then this one is, let's see, negative 768 equals our first term times r to the fourth. Okay, so let's solve both of these for what we're wanting to solve for anyways, right? A sub 1. Okay, so how would I do that? How do I get a sub 1 by itself for the first one? Yeah, divide both sides by r. So we're going to divide both sides by r. We're going to divide this by r. So for the first one, the first term is equal to 12 over whatever the common ratio is. For the second one, I'm going to divide by r to the fourth. Divide by r to the fourth. So I get a sub 1 equals negative 768 over r to the fourth. All right, all right, all right. I'm going to use substitution. A sub 1 equals this. So instead of A sub 1, I'm going to write that. That makes sense? Or another way to think of this is both of these are equal to A sub 1. So this has to equal this, right? If they're both equal to the same thing, they have to be equal to each other. So 12 over R is equal to negative 768 fourth, right? This is where cross products comes in. So we'll go 12R to the fourth equals negative 768 R. We're getting closer. I'm going to divide both sides by 12. So let's do that. 12 divided, or sorry, 768 divided by 12 is 64. So R to the fourth equals negative 64R. I'm going to divide both sides by R. Usually we don't want to do this, but we're going to do this in this case because there's one ratio. So that'll be okay. I know it's weird to like go against the rules that I've said before. R cubed is equal to negative 64. All right. And some of you may know this. This is going to be R is equal to negative 4. Okay. If you don't know it, you can use your calculator, right? So we're going to go, oh, I'll use a new calculator. Oh, I don't have a new calculator. You could use your new calculator, right? Remember to solve this, you would cube root both sides. So R is equal to the cube root of negative 64. Cube root is also the 1/3 power. So on an old calculator like I have, I could do oops, I'm going to put it in parentheses, negative 64 raised to the, and then in parentheses, 1 divided by 3, right? 1/3 power. There we go. Oh, wow, you're not even saying what I did. There we go. So negative 64 in parentheses, keep that negative next to it, raised to the 1/3 power is negative. All right, cool. If you needed to use your calculator. So there we go. We got this. Now write an explicit rule for the nth term. The nth term is equal to the first term. Did we find that out yet? Didn't find it out yet. Silly Mr. Rebuff. All right, I still got to find A sub 1. So I just have to plug this in here, right? I could plug it into either one. I would much rather plug it in here. So the first term is 12 divided by negative 4. That's going to be negative 3. So negative 3 times our common ratio, negative 4, raised to the n minus 1. And there we go. Cool? Cool. That was kind of nasty, wasn't it? But kind of fun. It's the same idea, right? What do? We made two equations. We solved them for the same variable. We set them equal to each other. We found the R. And just like with two equations, two variables, once we find that, we've got to plug it back in to find the other variable, which was helpful. Then I have those two things and I just plugged it into the formula, right? Plugged it right in. All right. Last time we did one additional practice together. I think we're going to do the same thing here, I think. Yeah, let's do number 2 together because it's a little tricky. Okay, kind of the same as last time, right? So same thing that we just did in the last problem, but then is this a term? 2048. It's like the game. It's so fun. Okay, sorry. A1 is 2, and the common ratio is 4, right? And that's all I need. Common ratio is 4. So with those two things, can I write the formula? I can. A sub n is equal to A sub 1, which we have, times the common ratio raised to the n minus 1. There we go. So step number 1, find the formula or the rule for finding these terms, right? The next thing I'm going to do is I'm going to say, well, could this be a term? Well, let's go. 2048, is that equal to 2 times 4 to the n minus 1? This is tricky, y'all. A lot of different ways to play with this. The first thing I'm going to do is divide both sides by 2. Hope you're okay with that. 1024 is equal to 4 to the n minus 1 power. We've got a couple different options. All right, I'm going to show you two different options. Okay. So two different options. Number one, we have a thing that says if you can get this and this to have the same base, you're golden, right? So can I make this one be 4 to some power, right? That's my goal. Can I turn this into this? And if I can, then I can compare them. So I'm going to grab my calculator and guess and check. Watch this. 4 raised to the, I don't know, fourth power, 256. I need a little bit more, but not a lot more, right? Oh, maybe 4 to the fifth, 1024. That's what I'm looking for. All right, so 4 to the fifth power is 1024. I knew it was a power. I knew it would work. I just didn't know what number it would be offhand. So little guess and check, right? Took 2 seconds. It worked. We're feeling good. All right. So if this is true, then n minus 1 has to equal 5. So n has to be 6. So is this a term? Yes, it's the sixth term. All right. For those of you like, I don't like a lot of guess and check, Mr. Rebuff. I want to do some crazy math to figure it out. Well, guess what? You can. Let's change it to this and see if you can go back in time about one chapter. We have an exponential and our variables in the exponent. How do we undo exponentials? Logarithms, right? In my class, we have this thing called the base stays the base and the others change place, right? So if I want to turn this into log, I'm going to write the word log and I'm going to note the base of the exponent, and that becomes the base of the log. And then I'm going to write an equal sign. And then the other two things, this thing and this thing, are going to change place. So log base 4 of 1024 is equal to n minus 1. And now I'm going to go into my handy dandy calculator and go log base 4, 1024. Um, um, and I think I get 5 when I do that, equals n minus 1. And this should look familiar, right? Because that's what we had here. All right, so n is equal to 6. So either way you want to do it, you want to go into log time. Awesome, have fun. If you don't want to go into log time, you can use this method. Okay. If this method doesn't work, right? If you get something in between whole numbers, like 4 didn't work, 5 didn't work, but it's in between those two, then you know that it wouldn't be a term, right? It would be stuck in between integers. All right. And that's it. I think that's it. All right, people. Only one more section here of nodes. We'll hit them next time. That's going to be recursive coming up. We hinted at it in 8.1. We're going to jump in and do it in 8.5. Sound good? All right, people. We'll see you.